Hello everyone. So today we are going to do Leetcode daily challenge. Find three cameras. So basically in this question we are given with a binary tree, and in that binary tree we are required to return that how many cameras, means minimum cameras we could insert so that its parent root is we can't say it as root, but its parent node. Its parent node is monitored and its child nodes are also monitored. So in that sense, we are required to insert the camera. So the first thing is that inserting a camera could be something like that. Even if we are given with something like this, means let it be. If there's something like this, and we insert our cameras here, right? Then it will monitor these nodes easily, right? And then for monitoring this particular, we can insert a camera here also. Then it will monitor this. But this doesn't need to be the minimum, right? Because here is camera, 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 right? But the thing would be that this is not a minimum, and another thing would be that although it will be fulfilling all the conditions that now all the nodes are covered, but the criteria that we are required to return minimum won't be fulfilled by this approach. So we need to think in some other terms. If we are given with a tree something like this, then how we could do? See, if we fill up this level, then yeah, we are also required to fill this level also to monitor this, right? But if we fill this level only, right, if we exclude this level, then by filling this level, we are having camera here and camera here, right? So it will be able to monitor this also and this also. It will monitor this also and this also, right? So this would be somehow, earlier we were filling 1, 2, 3, 4, 5. Earlier we were having 5 cameras, and now we are having only 2 cameras, and all are monitoring each and every node, right? So this is the better approach, rather than we start from the leaf node but we start filling from the leaf node. That is not the right approach. The right approach is here that we start, even if we start from leaf node, right? Means when we would be doing DFS, then we'll surely reach at this leaf node only. So rather than filling this particular leaf node, if we start filling its parent, right? So then we will be able to get appropriate answer, basically the minimum answer. But there could be some case like this also, right? Here when all of them are already covered, but still this is uncovered, right? So in this scenario, we need to handle this case explicitly by adding 1 to this particular case when we would be returning answer. So in that scenario, we would be having 3 cameras. So this is thing how we will be like handling this edge case for this particular question. So let me explain you more about this particular problem. So the thing is that we are given with a node. I know my cursor won't be visible to you. That's why I need to highlight. So where is it? Okay. So we would be given with a tree like this, right? Every node would be having 0, 0, right? Like this at the start, right? But the thing is that we are required to return minimum number of cameras. If we insert a camera at this particular position, right? So our node will change to 2, and this will change to 1, and this will also change to 1, and this will also change to 1. Basically, what these 1, 2, and 0 are, basically we are considering them as states. The thing is, this question is purely based on DFS, means I'm doing this in recursive manner, that I'll go into depth of that particular tree, and while returning, means when I'll reach at the leaf node, from there only I'll start filling up the cameras, but not at the leaf node, but the parent of the leaf node. So in that sense, I'm approaching this particular question. So the thing is that we would be having these 3 states, 0, which refers that it is unmonitored. At the start also, we are having tree with all the unmonitored nodes only. So that's why I've taken 0 as unmonitored. Then 2 would be the one where I will be inserting the camera. Basically, I'll change the state of this particular node that now it is having a camera, and one would be that state when I will say that it is already monitored by the camera. See, when I inserted this particular 2 into this 3, then I had already changed the state of other nodes to 1, so that it represents that now these nodes are already monitored. And these all things we would be doing while doing DFS and while returning values to our parent node. So it all would be covered in the coding itself. Presently, I'm just explaining you the approach that how we are required to think of this question and how we need to go ahead. Now, let me show you the dry run of this code so that it would become much clearer for you that how we are required to approach this particular question. Now we are given with these 4 nodes. Basically, this 3 only I've drawn here. So how we are required to go ahead is, see, first thing would be that we would be going down and down because of DFS, right? And then again down because of DFS. Then when it reaches the null condition, as it is null, this refers these both of them would be null. So here, as it is null, right? So we can say that now it is reaching, it has already reached a leaf node. So when the child of the leaf, basically when the leaf node's left pointer would return, then it will return the state 1. This is the thing. And then when because now it was just left call, now it's time for the right call also. So when it will go towards its right subtree, right? So here also it encounters this null, then here also it will return 1 only, right? From both of the direction, or even if either of the direction, if it would have been getting 1 value, so now it will return as 0 to its parent node. Why we are returning 0 here? The thing is that we don't want to fill this leaf node, right, with the camera. That's why we are returning 0. And this signals its parent node that this particular node is now unmonitored. So that's why now I am required to have camera on myself. So that's why when it returns 0 to its parent node, so in that scenario, now it is having 0 from this side, then presently this was for the left call only, right? Now it is also having its right call with it. So it will go towards right subtree, and there it will check that what is the scenario I'm getting from my right subtree. So from here it will be, now this is also a leaf node only, right? So again the same scenario would be there the way it was here. So here also both of them would return 1, right? So here again both of the nulls would return 1, right? So when it returns 1 from both of the sides or even either of the sides, then it will again return 0. So now this particular parent node is getting 0 from both of the directions. So that's why it will return 2 to its parent node. Why it is returning 2? Because it got 0 from its child node, and that's why it simply know that now my child nodes are unmonitored. So that's why I want to be the one which would be having the camera. So that's why it is returning 2, and at this point only the camera count will also increase. Now comes the next part, means at the parent node itself, means the uppermost part. Now here the scenario would be that it is getting 2 from its child, right? So in that scenario it will return 1 to its parent caller. So now this was the root node itself. So from our whole function, this 1 would be returned, and the camera value would be also 1 because we have inserted our camera at this particular node, means only one node has got inserted with the camera. So at the end, now what this DFS would return would be 1 only for our DFS. So when DFS returns 1, right? So at that scenario, we'll return our camera count itself. But if it returns 0, then at that scenario, we'll return the camera count plus 1. Why plus 1? Because of this fact, means this example which I had given you Oh, okay. I'd given you at their side. Means when we are having a tree, something like this, right? So in this scenario, it will return 0 here, again it will return 0 here, it will return 2, and here it will return 1, right? So when it returns 1, so it is required to return 2, right? But it won't be because okay, sorry. So here 0, then it will return 2, but here it will return 1. So when I get 1, right? So in that scenario, because I got 1 from that side, so that's why here it will be returning 0 only, because when here we were having these leaf nodes, these were also returning 1 only, right? So it will return 0. So our overall DFS function will return 0 here, right? So when we got 0, but one more thing is there, that this particular node is now unmonitored. This one is having camera, so it could monitor this node, and this node. But this node is neither this one is having a camera or any other node with this, basically don't have any other nodes, right? So this remains unmonitored. So that's why when DFS returns 0, so at that moment we are required to return 0 plus 1. So because of this only, we will be returning camera plus 1. That is the count we will be getting from this camera, and the one for this particular unmonitored node. Else we will be returning our camera itself, basically a camera count which would be there. So this was all for this particular question. Now comes the part of time complexity. The thing is that we are just doing DFS, so that's why our time complexity is order of n, and the space complexity would be again order of n. This is in that scenario, basically the worst case scenario, when it is a skew tree, and even it could be log of n when it is a complete binary tree. So here, rather than taking the n or log n, we will taking it as h, where h will belong from n to log n, means the range would be this one. So that's why our time complexity is order of n, and our space complexity is basically order of h. So this was all for this question. Now let me walk you through the code, because from there you will get more clearer idea that what exactly it's required to do here. So now the case is this one. So the thing would be that when we are, this is a scenario which I have told you, that from that DFS, when it returns 0, then we are required to just return camera plus 1. Basically camera count which would be there, and plus 1 for that unmonitored node. Else we would be returning camera itself. So this is the thing. And now comes the next part, means our main part which is there. So here we are, what we are doing is, we are basically, this is for that fact when we are having child node of the, basically there it won't be having a child node, but that leaf would be having those, leaf node would be having null towards both of the side, right? So at that moment it is required to return 1. So at that moment it will return 1, because node equals null, right? Means when we get to leaf node, then here it is null and here it is also null, right? So when we reach at this particular position, so it will return 1. It will also return 1, so that it could return 0. So this is a scenario which would be followed here. Now for left subtree, for right subtree, so when both of these subtree are reached, then it will reach the leaf node, right? So it will check that if left equals to 0 or right equals to 0. So in that scenario, it will increment the camera. Basically this will return 0, right? So here whatsoever parent node would be there, so it will return 2. So that is what we are, but also it will increment the camera, because here we will be inserting the camera. Else if left equals to 2 and right equals to 2, so this would be returning 2 to its parent node, right? So in that scenario it will return 1. So basically this particular node will return 1, means this will return 1 to its caller, so which represent that it is already monitored now. So at the end, it will turn 0, and this will return 0 in that scenario when there would be 1. In either left or right would be 1. Basically, in this scenario, it will return 0. So this is how we would be doing DFS for this particular question, and these are the states because of which we are memoizing. Else if we would have been doing it directly through traversals and without defining any states, then surely it will give us TLE. Now comes the next part that I hadn't even explained you the question according to the constraints also, that why it would be giving us TLE. So now here the thing is that number of nodes are basically 1 to 1000, right? And the node value is only 0, right? So the number of nodes which are there, they are almost in the range of this 1 to 1000. Even if it is skewed, then also we are traversing the whole tree, right? But the thing is that every node is having the same value, and then again we are not even able to know that exactly where we are required to return that particular camera. So for creating a scenario that yes, this node has already been visited and we don't need to visit this particular again, and why we are required to basically for this present node, why we are required to get the camera here or not. So in all those scenarios, we are required to maintain all the states so that we could directly return that, yeah, in this scenario we are returning this state, so here it would be having the camera, else it won't be having. So in all this scenario like this, we would be memoizing this particular solution, and the time complexity and space complexity I've already explained for this solution. So yeah, this was all for, wait a minute, have I explained? Okay, time complexity and space yeah, 1 minute. Time complexity, yeah, so this space complexity which I've explained, it is for that stack, means how much it will acquire at a particular moment. This is basically for the recursive stack only. Actually, the thing which came to my mind was that I hadn't used any extra space, so why space complexity is there? So the thing was that because of this TFS solution only, yeah, that's why space complexity is of that recursive stack. So this was all for this particular question. If you have any doubt, you could comment that down. So this was all for this. Thank you.